Okay. Yeah. Morning. Okay, we have another 1 minute and then we start the class, okay? So please look at the given note, chapter 5, chi-square test, eh? So how's everyone? This week, do you have any tests? Hello? You can hear my voice, right? Okay. So how many tests you have this week? So today, do you have any tests for today? 4? Okay. Only our tests. Today you have tests? Oh, okay. Okay, so let's start our class, eh? So today, just a very quick review on chapter 5, and then we're going to do some revision on our test 2. Maybe on Wednesday, maybe we're going to do some on Wednesday we're going to do some exercise on chapter 5, or maybe I will give you a time for you to study for your test 2. No, we don't have quiz this week. Maybe next week. Okay, because I want to give you time to do your testing. Okay, so let's look at chapter 5, chi-square test. So have you looked at my video? So if you notice that in the videos, there are some mistakes that I made in the slide, but I have already made correction in the slide. Okay, so the slide, the mistakes already corrected. The videos is the last semester video, so I'm not sure how to edit that video. Because of that, I just gave you the video, but I already made correction in here. So just a quick review on chapter 5. So basically the chapter 5, we have the goodness of fit test, independent test, and homogeneity test. So we have 3 types of tests. So I'm sure that all of you have already looked at the notes and the videos that I've shown you. Okay, but I just want to tell you some of the parts that I didn't tell you in the videos. For example, this example 2. So this example 2 is about the Poisson distribution. So we want to check, we want to make a hypothesis whether the population, whether the random variables, is it following the Poisson distribution or not. So in the videos, I have shown you how to find the probability of Poisson using the table. But actually, you can also find the probability of Poisson without using the table, which is by using this formula. So you can still get the same values for your probability, okay, using this formula. Okay, so you just sub in the values of your lambda x into the formulas and you will get the result. Except for the last one, since we have px more and equal to 5. Okay, so we have to do like this. 1 minus px less and equal to 4. So here, to find the value of px less and equal to 4, you have to add all the values from px is equal to 0 until px is equal to 4. So 1 minus the summation of all these probabilities. Okay? So here you will get the same probabilities like in the table. Maybe the only difference maybe 1 to plus minus 0.0015, like something like that, the difference, but still acceptable. Okay? And then this one, why this one is more and equal to 2? Because the summation of all this probability should be equal to 1. So since this probability is already covered 1 to 1 and less than 2, so that's why the last one it should be more and equal to 1. Okay, because this one it doesn't include number 2 here. However, when you do the statistical table, okay, you could consider this one is equal to more. Okay, if you do using the statistical table. So that's why in the video I said this one it could be more as well, because we use the statistical table, the formula is more. Okay, so I think this one no problem. This one question 1B. So I want you to do this question 1B. Make sure you know how to do this question 1B and this question 8 as well. Okay. So previously in the previous slide, I have shown you that the formula for your chi-squared is chi alpha k minus p minus 1, right? However, the previous example, the value of p is 0. So what is p? So p is for unknown parameters. So remember, parameters is the symbol for your population. Okay, which could be, for example, mu, variance, lambda, something like that. Okay, so P is for unknown parameters that needed to be estimated from the data. So since last examples, okay, it doesn't ask us to find the unknown parameters. So that's why we considered here the P is equal to 0. However, for this case, if you notice this example B, okay, so this example is about the Poisson distribution. However, the value of lambda or the value of the mean, okay, so the value of the mean for Poisson distribution is not given. So the mean is the population parameter. However, for lambda, it is symbolized as lambda. So since the value of mean is not given, so we have to find the value of the mean lambda. So that's why here the value of your P would be equal to 1. Okay. So please be careful on this question 1B. And then you need to find the value of your lambda by your own. So how to find the value of lambda? So here the value, the lambda means the average or the mean of the data. So that means you have to find the lambda by finding the mean from this data, which means 0 times 32 plus 1 times 15 plus 2 times 9 plus 3 times 4 divided by n is equal to 60. Okay. Okay tak? Any questions? No questions, I just proceed. And for this one, this question 6, okay, so this one is from another subject. So here the random sample given is 175. However, when you make a total for this one you won't get the number of sample is equal to 175. So just want to make sure that when you're doing the goodness of fit test, you use the n from the given random of sample from the statement given. Okay, however, if the number of sample is not given here, you can use the n from here. Okay, so here it is not the same, right? So you use this 175 as your n. Okay, I think that's all for this chapter. Okay, any questions for this chapter? Or you haven't studied this one yet? Okay, so make sure you finish all this chapter. So this week we must finish this chapter. Next week we are going to start a new chapter which is ANOVA part. So any questions on this chapter? No. Final all chapter. Okay. And I think the last 3 chapter, which is this chapter ANOVA test and simple linear regression, is not as difficult as the previous chapters, chapter 1 until 4, because the question is very direct and normally students will get marks from the last 3 chapters. Okay, last 3 chapters will help students to get marks. However, if you do one mistake, okay, it will lead you to another mistake. So make sure do careful. Please do careful when doing this exercise, when do this examples. Okay. Because for example, if you got wrong calculations for E11, okay, you also will get wrong calculation for your chi-square test. So please be careful. Okay, so if there is no question for this chapter, no questions. If there is no question for this chapter, let's look at your revision for your past year test 2. Okay. I have looked into your answer for quiz. So let's look at question 1. So this question 1 is about population means. So I have collected some of your answers to show you what you should improve, what you should be careful while doing these questions. Okay. So here, if you notice the number of sample for this question 1 is 35, which is more than 30. So please remember, when the number of sample is more than 30, you don't have to check for the variance equality. Okay. Okay, here. Adalah. Ni salah. Sekejap kelas. Did I give you this formula in your slide? Yes?
Yes, sir.
Sekejap Oh. Sekejap. Apa dah? Sekejap ya. Betul lah. Okay, sorry. Kejap. Kena padam. Sorry, I lupa pula. Okay. Okay, here. If the number of sample is more than 30, okay, look here again. So if your number of samples is more and equal to 30, so we have to check for the assumption whether the variance is equal or not. However, for this case, like what I told you before, if the question doesn't specifically tell you whether the variance is equal or not equal, we assume that the variance is unequal. So for example, for this question, it doesn't state right whether the variance is equal or not. So we assume that the variance is unequal. So that means we have to use the formula from the case 3. Okay? We assume this one. So you don't have to do the hypothesis testing to check for the variance equality. Okay? However, if the question stated that the variance is equal, so you have to use case 2 lah. Okay, so now let's look at the answers that I collected from your friend, from you lah. Okay, so here, this one already correct. Okay, this one is correct. Okay, this one is also correct. However, this one, since Z test lies in the rejected region, So here the rejected region is negative 1.6449, right? And now your z-test is here, correct? So this one is in the accepted region. So why this one is lies in rejected region? And then you said H null not rejected. Okay, if your z-test lies in the rejected region, so that means you have to reject it. Chungtek, be careful because this one we have mark for this one. Okay, so this one is wrong, but this one is correct. But because this one is wrong, so I won't accept this answer. Okay. So make sure you do careful while doing this one. Everything is correct except this one. And then this one, no need to check for the variance equality. This one I already mentioned to you before. Okay. This one. Why mu2 is bigger than mu1? So here we have mu2 minus mu1 is also equal and less than 8. And then here we have mu2 minus mu1 more than 8. However, if we look at the questions, the question state that, okay, the 10 diameter, so this one is what your friend did is mu2, right? Wait. Okay, mu2 is for 10 millimeter. And this one is mu1. Okay, so here 10 millimeter diameter steel rod should be at least. So another important one while doing the hypothesis testing, you should know the symbol for at least. So the symbol for at least is this one, right? Okay. So at least is this one. At most is this one, correct? Not more apa not more? Not more. Not more this one, right? Betul tak not more? Not more than. Okay. Okay, betul And then apa lagi? I tengok sekejap simbol-simbol apa yang ada. And then we have, okay, kejap tak ada apa lagi? Greater than, higher than, less than. You should know this. What does these symbols mean? So you can go to Google, just search, for example, symbols for. You can search, for example, symbols for not more than, and then they will show you another symbols like this. Okay. So for here, the mu2 is at least 8 units higher than the tensile strength measurement for 8 millimeter diamond at diameter steel rod. So that means, okay, mu1 plus 8, right? So mu2 minus mu1 more and equal to 8. So automatically, okay, the second row it would be less than 8. So this one, okay. Okay, this one, please be careful while doing these symbols. Okay. And then you can also, if you want to do for example, if you want to do, here we have, for example, the correct one, more and equal to 8. Another one is less than 8. You can also do like this. For example, if you want to do mu1 minus mu2 less and equal to -8. Another one is mu1 minus mu2 more than -8. Okay, you can also do like this. However, when you do your z-test, make sure this one also, you should start here with mu1 and this one is mu2. So that means this one should be 539 minus 543. Okay, so you can do the what we call the reverse of this. However, the z-test, it should be reverse as well. And then the condition for your z alpha also must be changed. For example, this one is more, right? So when the second row is more, so that means, okay, you have to check for the rejection region also will be changed. So z-test more than z alpha, then you will reject your hypothesis. Okay, for the previous one, we use this case, right? So that's why we choose this one. Your z alpha, it should be negative z alpha because we use the second case for the previous example. For this one is negative z alpha because this one and this one is z alpha. Okay, please be careful when doing this. And for this one, what's wrong with this question? No need to do sample distribution. Okay, this one you no need to do sample distribution. You don't have to. And then what is wrong? Another part. Okay, this one, the z-test formula. Okay, here, this one, it should be at this side. And this one, it should be at this side. So please be careful when doing your z-test. Okay, so this one is wrong. This one, another. This one, I think it shows perfect steps when doing this hypothesis testing. This is the answer that shows the perfect step. So first we do the hypothesis testing, and then second we do the z-test testing, and the third one we do the decision rule, and the fourth one we do the conclusion. So this is the perfect steps. But the only thing that is wrong is on this one. Okay, are you sure that negative 0.9239 is smaller than negative 1.6449? Okay, so please be careful. So here is negative 1.6449. Negative 0.929, it should be around here. It should be bigger. Okay, like for example, negative 2 and negative 1. Which one is bigger? Of course lah, negative 1, right? So this one, you also need to be careful. Okay, so this is the correct answer. Okay, this is the correct answer. Wait. Sekejap. Sekejap. I nak tunjuk you satu lagi. Ya. Mana yang tu? Suai tunjuk yang ni. Sekejap I copy paste satu jawapan ni. Okay, mana tadi? Okay, this one. Ini nasib baiklah perasan. Okay, share content. Okay class, let's look at this one This one also something's wrong here. Which part? This one, because you use the T instead of Z. Okay, so this is the correct answer So first you make the hypothesis statement, then you do the test statistics, then you do the decision rule, and you do the conclusion. So now you need to use the Z alpha, not the T because here when we look at the formula here, okay, here we use case 3. So we use the Z test, not the T test. Okay, so please be careful when doing this. So you use Z alpha, not the T So this is not the correct answer, this is wrong. So please check again your answer for this one. Okay, let's see another one. Okay, this one is correct. Okay, this one is correct. Okay, so this is the correct answer. So I will give you this slide into your e-learning. Okay, any questions for these questions? No. So if no questions, let's look at another example, Okay, so this one is also quiz question. So most of you got full mark here, question 2. So I don't think this question would be any problem. But let's look at what mistakes that your friend did. Okay, this one. Where is your decision rule? Okay, so suddenly you said there is significant difference between the properties of employees from state A and state B. So where is the decision whether you reject or accept the hypothesis? Reject or accept? So you cannot give two questions I won't accept it. Okay, you should decide whether reject or accept only. Choose one only. Another one. Ni I tak ambil Alamak, mana yang ni Kesalahan ni? Ke yang ni? Kejap. Yang ni. Hypothesis testing should be for population class. This one is for what? This one is for sample. Okay, so the correct one you should use this symbol, the pi. So pi is for population. This one is P. P is for sample, not for population. Another one here you use the P value. Okay, so this is this is wrong for the P value. I haven't teach you about the P value, right? So the P value is not included in our syllabus actually for chapter 4. But I can teach you how to use the P value. Okay, another one, what is wrong with this question is that here, your hypothesis testing is a two-tailed test, okay? So that means if your alpha is 0.01, you should divide your alpha with 2, okay? So what's the difference between the z-test and the p-value? So the p-value is actually, so for example here, okay, so we have z-test and we have the z-alpha. So the z-test and the z-alpha, this one is the value at the line here, at this line, However, the p-value and the alpha, it is the value inside the region. So for example, we have alpha, right? So this is the alpha. So alpha and this one, we have another, what we call this one, p-value. Okay, so alpha is the area of the region. So for example, if your alpha is 0.05, so this is the area of the rejected region. While the p-value is the area of your z-test, which is this one. So if your p-value is less than your alpha, okay, so we need to reject the hypothesis testing. Okay, while for this one, if your z-test is more than your z-alpha, we reject the hypothesis testing. So this one, if your p-value is more than your alpha, we reject. But here, it is less. This one should be less lah, because the area of the p-value is less than alpha. Okay, the area is less than alpha, then we reject the hypothesis testing. But for this one, z-test more than z-alpha, we reject hypothesis testing. Why? Because this one, it is more, because it is on the line, right? So since the z-test is more on the z-alpha, this line is higher than this line, so that's why we reject the H naught. Okay, so if you want to use alpha, use this one. If you want to use the z-test and z-alpha, use this one. But in our class, in our syllabus, it is better for you to use this one lah. I don't want you to confuse with this one, with the p-value. So if you don't know how to use the p-value, don't use this. Just use this one. You still get the same conclusion. Okay, so this is the correct one, eh? Okay, any other questions for this one? For your quiz? No questions? Any questions tak? No? No, eh? Okay, okay. Sekejap, Mana hypothesis testing untuk, okay, kita show. This one is for example, this one. Okay. Okay, can you see this one? This question? Yes, eh? So this question, I have already gave you this in your WhatsApp group. So for this one, they want you to find a 90% confidence interval for the population standard deviation. So remember, so for the confidence interval, if they want you to find the population standard deviation, so here you do the steps like normally what you did for the variance, for the confidence interval for the variance, okay? And here you will get the confidence interval for the variance. However, since the question asks you to find the confidence interval for the population standard deviation, that means you have to do the square root for both of your population variance. Okay, so don't forget to square root and then you will get the confidence interval for your standard deviation. This one is for the confidence interval for the standard deviation. And the second one is on this one, Run the hypothesis testing for the true standard deviation. Okay, here they give you the standard deviation is equal to 12. So here you need to be careful. You need to be careful. Sometimes the value given is for the variance, sometimes the value given is for the standard deviation. However, for this case, since the value given is for standard deviation and they ask you for the true standard deviation, so what you should do, so for this case, okay, for hypothesis testing for standard deviation, you just do like the hypothesis testing for the variance. However, for this one, you need to square your standard deviation. Since the standard deviation given is for, since the value is given for standard deviation. So that's why you need to square your standard deviation for this hypothesis statement. Okay, and then don't forget to square this one as well. Okay. And then wait another one, the last one. The last one. Mana? Sekejap ya, saya nak yang ni kejap. Okey, kejap. Saya nak edit kejap. Okey. Aku pula boleh conteng. Okay. Another one is for this question. Okay, for question 2, this one, if you notice your past year question, this kind of questions quite popular lah. For example, this one, they will ask you to conclude, for example, whether the variance of time spent by both genders are equal. So here you will get, for example lah, okay. So for example, we need to find 90% confidence interval on the ratio of variance, right? And then for example, the confidence of the ratio of your variance, you will get, for example, 0.5432 and 6.6566, for example. So this is the confidence interval for your variance. Then the question asks you whether the variance of time spent by both genders are equal. So, for example, if we have the male and the female here, okay, so if the variance of both male and female is the same, so it should be variance of male should be equal to variance of female, right? So here variance of male divided by the variance of female is equal to 1. Okay, so since the one here, it is inside this confidence interval. Okay, so the one is inside the confidence interval. So that's why we could say that the variance for male is equal to the variance of female. Because this one, okay, the ratio of male to female is equal to 1 is inside the interval. Okay. So I think that's all kot my concerns for your test 2. Okay, is there any other questions for your test 2? I think that's all for today. Is there any questions? Ready for your test 2? Ready? Okay, so please study chapter 2 and do all the exercise given in the WhatsApp group last week. Okay, make sure you prepare well. Be careful when doing the hypothesis statement. And make sure that you know all the symbols at least, at most, not more than etc. Okay, so I think that's all for today. So if you don't have any questions, please scan the QR code here for attendance. This one. Scan your QR code. Yes, we have project this semester. After test 2, I will give you the project. It's a group project. Okay, you have to make a video for that. Ada. Nanti I share to you. Tapi tak adalah yang I conteng tadi, tak ada. The one that I scribble just now is not included in the slide. Okay, so I will share my slide in the e-learning. And also I noticed that some of you did not take the quizzes. So that one I cannot do nothing. I will give you 0 because you did not take the quizzes. And you did not inform me why you cannot take the quiz. Okay, so if you have problem, please tell me, especially for your test 2. If you have problem with internet connection ke apa ke, please tell me before the examination. Kalau take the quiz but didn't get it correct, also got 0. I will take the best 2 of your quizzes. Okay. Okay, any more questions? No? Okay, I think that's all for today. Please try do the chi-square test. Maybe we won't have class on Wednesday. I will give you time to do self-study for your test 2. However, make sure you study for your chi-square test. And if you have any questions for chi-square test, especially on the exercise given to you in the slide, please ask me in WhatsApp group, because next week we are going to start with new chapter. So I think that's all. Thank you everyone. All the best for your test this week. And for the subject as well, all the best. Okay, bye. See you on Thursday night. Our exam on Thursday night.
Thank you.